In this next example, I have a rational expression, and the denominator has what we call a repeated linear factor. It has a linear factor of x minus 4, but it's repeated, meaning the exponent is greater than 1. In this case, it's 3. Okay? So what we essentially have are three factors of x minus 4 times x minus 4 times x minus 4. Now, when we separate this off using the partial fraction decomposition, it turns out that the situation, the ideal situation for the numerator is to be all constants because this is a linear factor. Again, the numerator must be of degree less than the denominator. So if it's a linear factor, the degree on top has to be 0. All right, and so what we're going to end up with is a linear factor. However, every possible combination of the denominator needs to be included in the possible fractions that make this up. So what I mean by that is the original fraction 2x plus 3 over x minus 4 cubed must be equal to the sum of three fractions. The denominators must be each of the powers of this, x minus 4. So you get x minus 4, you get x minus 4 squared, and you've got x minus 4 cubed. These are all of the three possible combinations that when added together give you an LCD of x minus 4 cubed. So basically you have to include the potential for each power less than 3 to be a possible factor here, or a possible denominator. And again, the reason for that is because if you only had x minus 4, where'd the other two factors come from? You need some terms that have all of the factors on the bottom. So you need x minus 4, you need x minus 4 squared, and x minus 4 cubed. Now it's possible that some of these, particularly the lower ones, may have a numerator of 0. In other words, we didn't need that fraction. However, we don't know that off the bat. So it's possible that any of these three denominators could be used to get an x minus 4 cubed as a final denominator. Okay? And then again, the numerators just need to be of lower degree than the x minus 4. So they have to be constants. Okay? ABC. I'll just use ABC to represent those. And so now, again, just like we did on the last example with not repeated linear factors, what we're going to do is basically solve this equation. And we need to solve it for A, B, and C. Essentially, we'll be eliminating the x's. Okay? And we'll be grouping the x terms together and working with their coefficients. And so to do that, we're going to multiply both sides of this equation by the least common denominator, which is x minus 4 cubed. All right? So I'm going to multiply on the left, do it here, by x minus 4 cubed. And then on the right-hand side, cannot write my 3. On the right-hand side, each of these factors will be multiplied by x minus 4 cubed. It distributes to all three terms. Okay? So I've basically used the multiplication property or multiplication principle of equality along with the distributive property there. Then I'm going to cancel common factors. Well, here the x minus 4 cubed and the x minus 4 cubed cancel off. And I'm just left with 2x plus 3. On the other side, I've got one factor of x minus 4 cancels with one of those, so I end up with a 2 exponent. So it's a times x minus 4 squared. Okay? And then the b, on the b term, well, both of these on the bottom cancel off with 2 of them on top, and I end up with one factor left on top. So it's b times just x minus 4. And then, of course, here, all three of the factors on the bottom and all three on top cancel off, so I'm just left with a c standing all by itself. All right? And so from here, if I expand the right side, I'll start to match up the terms, the x squared, the x, the constants, and that will help me to start finding values for a, b, and c. So here on the right side, I'm going to evaluate, or I'm going to expand this. Might need a little more space. 2x plus 3 equals, so here this is a times, now x minus 4 squared, if I use my perfect square trinomial formula, it's the first term squared minus double their product plus the last term squared plus, now here I'm going to distribute, that is bx minus 4b, and then a plus c hanging out on the end. I'm also going to distribute the a here, so we're going to get ax squared minus 8ax plus 16a plus bx minus 4b plus c. So here's where the grouping is important. I'm going to group together all the x squared terms, all the x's, and all the constants on each side and set their coefficients equal. Well, on the left side, I actually have a 0x squared. On the right side, I have an ax squared. All right, I'm just looking at the coefficients of the x squares. If that's the only one on the right side, and there isn't one on the left side, then that means this a value must be 0, right? Those two coefficients have to be the same, so that leads us to an a value of 0. So right away I know this first fraction isn't really necessary, okay? We'll be wiping that right off. Now I have to match up the x terms. Well, on the left side I know that 2x is equal to, well, I take the x terms off the right, it's negative 8ax plus bx. But I already know that a is 0, right? And if a is 0, so this term becomes 0, zero's out. And so 2x equals bx, which tells me that b must equal 2, right? That works. And then my constants, well, I have a 3 on the left. That has to equal the sum of all the constant terms on the right, which in our case are 16a, negative 4b, and c. But I already have values for a and b, right? So I have a value of a equals 0, b is equal to 2, so this term here becomes negative 8. So I actually have 3 equals negative 8 plus c, right? If I put the 2 in for b. And of course, by adding an 8 to both sides, my c value is 11. Right? And so what that tells me then is that this original fraction is equal to, well, 0 in for a, I can eliminate that fraction, right? That fraction isn't necessary. The b value is 2, so it'd be 2 over x minus 4 squared plus the c value is 11, so that would be 11 over x minus 4 cubed. Final answer. All right? And now if I wanted to verify that that was true, that this original fraction separates or decomposes into these two, all I need to do is get an LCD and add them back together. Maybe as a quick check, I'll go ahead and run through that. Again, I wouldn't ask you to necessarily do this, but I think it's good practice to check these. So as a check, to get an LCD, I just need to multiply the top and bottom of the first fraction by x minus 4 to get the third power of that. So I'd have x minus 4 times 2 over x minus 4 cubed plus 11 over x minus 4 cubed, right? That's a times 2. Right, so that gives me the LCD. I just multiply top and bottom by x minus 4. Then I distribute on top. This becomes 2x minus 8. Right, 2x minus 8. My LCD, my denominators are the same, so I can just add that 11 back in. And that's all over the LCD. And of course, negative 8 plus 11 gives me the 3. So this becomes 2x plus 3 all over x minus 4 cubed. So there we have it. Okay, so just to verify that this is the original fraction, and we've successfully decomposed it. All right. Now what's interesting is on this example I had an x minus 4 cubed. That was our repeated linear factor. But we can start actually mixing these together. The repeated linear factor with the non-repeated linear factor, and we just have to treat them the same as we do if they're the only ones in the fraction. And so a real quick example of that might be something like x minus 5 over x squared times x minus 2. Well, here I actually have both a repeated linear factor and a non-repeated linear factor. Notice the repeated linear factor is x squared. Now you might think, well, that's actually a quadratic factor, right? It is quadratic, but it's also linear. Weird. It is equivalent to the quantity x minus 0 squared. X minus 0 being the linear factor, squared meaning it's repeated. Okay? So it is technically a linear factor that's repeated. All right? So, and then we also have a non-repeated linear factor. And that's the x minus 2. And so when I construct this, the equivalent form for this, I would just say x minus 5 over x squared times x minus 2 must be equal to 3 fractions. And the denominators are each of the powers, each of the lower powers of this factor. So it's x and x squared, and then the x minus 2. So I have to make sure there's a factor of each, and I need each power of any repeated factors. Of course, I need the degrees on top to be smaller than the degrees on the bottom, but again, not counting the repetition in the factor. So here, this needs to be constant. This one needs to be constant because again, it's a linear factor repeated. Oh, I don't want the same constant though. I want a different one. So A, B, and C. C again is a lower degree than that linear factor. And then we can multiply through by the LCD. I'll do this a little bit faster this time. So the LCD in this case is x squared times x minus 2. So I'll multiply that to the top on the left. I'll multiply that x squared and x minus 2 to each of the factors on the right. And I'm going to cancel whatever can be canceled off of each term. So the first term here on the left, everything cancels, and that's going to be a common theme. Everything will cancel off on the left side. So you get x minus 5. On the right side, I get 1x to cancel, so I get a times x minus 2. Here in the middle, both of the x's cancel. I get b times the quantity x minus 2. And then here on the right, the x minus 2's cancel, so I get a cx squared. Then if I expand all of this and match up my corresponding terms, I get x minus 5 equals ax squared minus 2ax plus bx minus 2b plus cx squared. Now this system might be a little bit harder to solve than the last. What I would do is combine my x squares again. There's 0x squared on the left side. And so one way that we do this, just to simplify our writing, is we say, okay, look at the x squared terms. The coefficients are 0 on the left and a plus c on the right. So that gives me one of the equations in my system. Then look at the x terms. Well, the x terms give me a 1 on the left, and let's see, a minus 2a, a plus b on the right. So that's another equation in my system. And then for the constants, the minus 5 in this case, let's see, so it's going to be a minus 5 equals, or sometimes we even go by degree. We might list it as a 2 degree, a 1 degree, and a 0 degree, or something like that. doesn't matter, as long as you understand what you're doing. Negative 5 equals, now if I look at the constants, the only constant is negative 2b. Oop. Negative 2b. So I have this system now, and what's really nice about this one is that I can immediately solve for b in this bottom equation. Often there's going to be a slick way to get through this. Sometimes it's just a big system with 3 variables and you have to work through using elimination or substitution. But here, if I divide out the negative 2, I know that b is going to be 5/2, right? The negatives cancel. That's 2.5 if you're looking for a decimal there. I could put that b value back in, and I can kind of work this backwards. So I know that 1 is equal to negative 2a plus 5/2. If I subtract 5/2, or if you like 2.5 from both sides, I'm going to keep it in fraction form. 1 is really 2/2, right? 2/2 minus 5/2 is negative 3/2. And then you divide out the negative 2, and that's going to give me, the negatives will cancel. The 2's on the bottom, right? 3/2 divide by 2, that's really multiplied by 1/2. So you double the bottom. This is really 3/4. So the a value is 3/4. And then the, let's see, that's b, that's a. And then we know that 0 equals a plus c. Well, if a is 3/4, well, c would have to be the opposite, right? To get 0 out and subtract the 3/4 over, so negative 3/4 is equal to c. And so now I have my 3 values. I can just plug them back in. Now it looks a little bit strange, understandably, to have fractions in the numerator. There's really 2 ways you could write this. One is with those fractions. So you could do 3/4. Actually, let me switch colors to get the final answer in here properly. Look kind of different. So 3/4 over x plus the b value is 5/2, so I could do 5/2 over x squared. And the c value is negative 3/4, so I go minus 3/4 over x minus 2. That's one way to represent the answer. And in fact, I think my math lab actually likes that, which is a little bit strange, but the other way to represent it, and this is the one I prefer, but again, I won't be picky, I would take this. The one that I like is just to take these denominators and put them on the bottom, right? 3/4 divided by x is really 3 over 4x. And so you could write this as 3 over 4x plus 5 over 2x squared minus 3 over 4 times the quantity x minus 2. That would be equivalent. I would take either of these answers. In fact, you could even distribute the 4 there. It doesn't really matter. I like them factored, but either way. And so either of these partial fraction decompositions will, when added together, equal this original fraction with the LCD.